Hello, and thank you for joining me today. I'm Çetinkaya-Rundel. I am a developer educator at Posit and a professor of the practice at Duke University. I mainly teach statistics and data science, and today's agenda is teaching the tidyverse in 2023. I am going to talk to you a little bit about the code base that has changed in the tidyverse over the last year. And really, when I say last year, I mean the academic year. And there's an accompanying blog post to this video that you are welcomed and encouraged to read through for more details as well. But before we get started with the tidyverse, let me start with a little bit of a trick for you. So this is usually what my RStudio IDE looks like when I get started teaching. This is sort of the color scheme, the theme I prefer to use when I am working on my own during the day. This is what I prefer when I'm working at night. And this is what I prefer when I'm teaching. And the way I've changed through these different themes is I've written a package that has a bunch of, like a personal package that has some add-ins for me. So I can quickly switch between teaching mode and modes that I like, themes that I like to use when I am actually working on my own. I recommend getting some shortcuts for yourself like this as well. So we are going to start by loading the tidyverse and the Palmer Penguins packages that we're going to use for some of our data examples. And I'm going to load two other packages, GT and package load. We're going to use these for just a couple things along the way. The first thing I'm going to talk about is the native pipe. Your tidyverse pipelines may have looked something like this in the past. You start with a data frame and then you pipe that into, say, a dplyr function like count, and the result looks something like this. Since R 4.0, you can now use the native pipe here as well, and you're going to get absolutely the same answer. So you might be wondering, why would I want to do that? Well, one of the nice things about using the native pipe is that it's going to work even sort of outside of the tidyverse or outside of loading the migrator package as well. So let's go ahead and restart R. So now none of my packages are loaded again, and let's add something else, something like start with the MPG data frame, or maybe even mtcars data frame, and then let's use a base R function like summary. Even though I have none of the tidyverse packages loaded or the migrator package loaded, I'm able to use the native pipe as well. So if you're teaching your students with the native pipe and teaching them to sort of build these tidyverse pipelines, they can learn that workflow and apply it beyond working with the tidyverse as well, should they be using, you know, a different package or in a different course or at some other point in their life when they're coding in R. Coming back to the tidyverse, one of the updates to the tidyverse was the tidyverse meta package itself. So tidyverse 2.0 was released in, I think, March of this year. Let's go ahead and restart our R session one more time, and let's go ahead and load the tidyverse package. We can see that in the past, we would also have to do something like add the load the LibriDate package separately, but we don't really have to do that anymore. So I'm going to restart. I'm going to show you that when I load the tidyverse, the LibriDate package is loaded as well. If you have not used the LibriDate package before or haven't taught the LibriDate package before, let's go through its functionality very, very briefly. Perhaps sort of the most important thing about it, as you can tell from the name, is that it allows you to work with dates and times, and these can be pesky things to work with. So let's go ahead and put today's date. This is right now a numeric variable, as you can see. Then I can use the LibriDate package's YMD function, so that stands for year, month, and day, and it will convert that, so it will parse that text into a data object for me. This probably seems pretty straightforward, right? I mean, we could have probably done this by sort of string parsing without the LibriDate package as well. So let's try something else. Let's make it a little bit more complicated. I'm going to put this as a text field. So I might say 7/19/2023. And we can say that the class of this new object, the new variable we created, oops, I should say today T, is a character. This is in the format month, day, year. So I'm going to use the mdy function. And LubriDate will convert that for me to a date object as well. And we can check that it does that. So mdy today t, and there we go. This is, I think, like a little bit more complex, but again, we could have easily parsed this string and said use the forward slashes as delimiters. So let's make something even more complex. Let's create something like an actual text string. And I will type here something like, this video is being recorded on 19 July 2023 at 1 p.m. ET. You can see that the class of this is a character. So how are we going to parse the date from here? Doing so with sort of string parsing would be a little bit more complicated. We would have to catch that 19 July 2023 there. That might take a bit of, knowing about regular expressions. But what I can do with LubriDate is I can say this is in the order, day, month, and year. And then there's also an hour there as well. And it will actually go in and try to parse out the sort of the date and time component from that text string. Now, the thing is, the time zone is incorrect. Time zones are additionally pesky. So you would, in this case, let's see, actually need to add the time zone itself. And now we actually have the right time there as well. And if I look at the class of this object that we now created, that is a POSIX-CT object. So LubriDate is pretty helpful for dealing with, pesky things like dates and times. And now it comes with the core tidyverse as well. Next, let's go back to when we first loaded the tidyverse package. So I am going to restart my R session and talk a little bit about conflict resolution. So what do I mean by conflict resolution? What I mean is that when I load the tidyverse package, you can see that there is a new updated message. It tells me that there are two functions in the core tidyverse, the filter and lag functions in the dplyr package, which masks the filter and lag functions, so the functions with the same name, in a package that is already loaded with base R, the stats package. This message has been here for some time now, but what is new in tidyverse 2.0 is that it specifically advertises the conflicted package as well. And you can always get back to this message even if you're not at the beginning of your R session with the tidyverse conflicts function, which will sort of print out the end of that message for you. So let's go ahead and unload that dplyr package. So we're going to take out the dplyr package and let's try to run this very sort of common tidyverse pipeline. I want to take the penguins data frame and filter it for penguins that are adelies. You've probably run into this issue before. If you haven't ran into this issue, kudos to you, but your students probably have ran into this. What's happening here is that the message that we get is not that it can't find the filter function. It can't find the dplyr filter function, but it is able to find the stats filter function, and it's complaining that it can't find this penguins object. Or actually, that is probably happening because we also haven't loaded the Palmer penguin. So let's go back and do that. It is complaining that the object species is not found. So it's sort of not understanding what you're asking it to do. The way we would base R would resolve this is if you then load the dplyr package, the filter function becomes available. And because it's been loaded after base R, we're able to R will just automatically choose the version of the function that was last loaded, and things work just fine. They work just fine until they fail. So if we want to be a little bit more sort of strict about how we go about things in terms of having multiple packages loaded with the same function names, we can leverage the conflicted package, which is not in the core tidyverse, but it is a tidyverse package. So I'm going to go ahead and load that. And once I load conflicted, I can no longer get away with just using the last loaded version of filter. It explicitly tells me, look, there are 2 packages loaded. They both have the filter function in it. Tell me which one you want me to use. One option is we can use the sort of the colon notation to say every time I use filter, I can explicitly say I want you to use the dplyr version. This is the sort of thing you might see in sort of like a package development scenario, perhaps, where you want to be very clear about where other functions from other packages are coming from. But I think in a data analysis scenario, this gets pretty busy, especially if you're teaching R, especially if you're teaching, dplyr for the first time. You're probably going to have a bunch of filter statements, and constantly noting them with dplyr : while not noting them for all the other functions that you're teaching, I think can get confusing for the students. So instead, you can be explicitly declare which version of filter you want to use. And there you can say, I want to prefer in this R session going forward, the dplyr version of filter. No more complaints from the conflicted package. And I am being very sort of explicit in my code about which version I'm using. So that was all about the tidyverse meta package. Let's talk a little bit about now the sort of improved and expanded functionality with joins. So much of these came with updates to dplyr with 1.1.0 onwards. I think as of today, we're at 1.1.2. So there's been sort of additional updates to get the rough edges sorted. But generally, these updates are mainly to better align with tools like SQL and data table. So we have here a sample data frame. So I've created an islands data frame where I have noded the coordinates of sort of the centroid of these 3 islands. And what I'm going to do is I am going to join the penguins data frame to this. So I'll take the penguins data frame and left join it to islands. And this should be a pipeline you're sort of familiar with. What we've done in the past was to use the by argument, and then in here actually denoted which variable from the penguins data frame, that's the island variable, should match to which variable from the islands data frame, that's the name variable. Instead, what we can do now is we can say join by, so a new function, and I will say where island is equal to name. So with this new notation that is available to you, you can actually read this out loud, how we often read out loud logical statements. So double equals is something we would read out loud as where x is equal to y. So now I'm able to say, take the penguins data frame, left join it to the islands data frame by where island is equal to name. I think that this, while the sort of the previous version, the syntax, the by syntax does not go away, I would strongly recommend updating your teaching materials to use the join by function. And the thing that is nice about that is that, one, this reading out loud is made so much easier and sort of aligned with how we read out loud other logical statements. And number two, when we work with the sort of the older version of this, so this we know worked, but some other versions worked as well. So I could also do something like this, and this would work as well, just because of how named vectors work in R. But this wouldn't work because it says I can't find this new name that you're talking about. And we also saw at the beginning that quoting both of these work as well. Options are good, but sometimes they can be confusing. So by using the join by notation, we no longer need to quote our variable names, which aligns much better with other functions in the tidyverse. Another update to join functions is where we have many-to-many relationships. So I'm going to create a few more new data frames just so we have them in our pocket and we can use them in our examples. One of them is data frame called 3 penguins, and this has 3 rows, so data on 3 penguins, and we have 1 row per sample ID. So imagine that you're a scientist and you're sort of collecting data on these penguin samples. So this is what my 3 penguins data frame looks like. And then we also have, maybe collected by another scientist, let's say, data on weight measurements of these penguins. And if you have ever done things like collecting weight data from, animals, you probably have done this thing where you had to measure at least twice. So we have this weight measurements data where for each of the sample ID of penguins, we have 2 measurements as well. And finally, we have 1 more, data on flipper length measurements of these penguins. So similarly, we've done 2 measurements per penguin. So let's say we have data from these 3 separate scientists and we want to bring them together. First, I'm going to start by bringing together the 3 penguins data set with the weight measurements data set. And there's just a one-to-many relationship and things just work fine. However, when I have many-to-many relationships, so remember those 2 scientists that each take 2 measurements from each of the 3 penguins, if I try to join those weight measurements and flipper measurements data frames from these 2 scientists, now I get a warning. So I get a warning that says that it detected many-to-many relationships between X and Y that was unexpected. And at the end of the warning, it says if a many-to-many relationship is expected, you can set relationship equal to many-to-many. Whenever I see, a warning like this, my first hunch is, okay, well, let's just try what it tells me to do. At least it'll shut up the warning, but maybe it will also be the right thing to do. So let's go ahead and add that. So this relationship argument is new with dplyr 1.1.0 onwards. And in fact, now we have explicitly said, yes, we were expecting this many-to-many relationship. However, let's think about this for a second. We started with 3 penguins, 2 measurements per penguin, so 6 rows of data, and we're bringing together these data from these 2 scientists, but all of a sudden I have this explosion of rows situation. I have 12 rows, and 12 is not a large number, but imagine if you had hundreds of measurements from these scientists, you would end up with this explosion of rows. So in this case, what we actually should be doing is instead of denoting a many-to-many relationship, we might actually think back to our data structure and say, no, I want to join by not just sample ID, but by measurement ID as well. So the join by function can take multiple variables, just like the by argument of joins can. And the relationship argument of the improved join functions is great for sort of catching in the tracks of making a mistake about how you're joining data sets, but the suggestions it gives may not always be the right suggestion for your use case. So don't just blindly apply the warnings, but instead think through your data structure to see how these should be coming together. And I think the teaching tip to take away from here is that when you're introducing these functions to the students, I would recommend doing something similar to what I've done here, which is iteratively sort of fall into the traps that you expect to fall into or you don't expect to fall into. Read the warnings, messages, or errors out loud, think through them with them together, and then apply some sort of solutions to the problem. The explosion of rows problem is something you have probably come across working particularly with new learners who will happily join any 2 data frames and sometimes, crash their R session, or if you're teaching on a teaching server, crash the whole server. So sort of walking through these sorts of examples with small data sets where they can see how the rows are expanding or contracting back to what we expect them to be, I think is pretty helpful. Another new argument is handling unmatched cases with the improved join function. So I'm going to make 1 more new data frame. This time my measurements include 1 more penguin. So I have 4 penguins in my data frame. And we're going to say, take the weight measurements from that 1 scientist and left join them to these 4 penguins. It's fine. R will happily join them for you. but poof, that fourth penguin is gone. Maybe you never wanted the fourth penguin, and maybe this is exactly what you wanted, but it is likely the case that this was a much larger data set, and some of these unmatched cases sort of silently disappeared, and you never caught them. So one option is to say, well, I definitely don't care any of the penguins whose weights I don't have. So I'm going to explicitly use an inner join to solve this problem, not a left join. So saying that I only want the penguins that are common between these two. Another option is to actually use the unmatched argument and say, when I do this join, anything that's unmatched, explicitly drop that. So again, the results we're getting from these is exactly the same. And in fact, you can also do nothing. You can do exactly what you did at the beginning, but do it at your own risk. So the difference between using the unmatched argument or not is basically saying that I'm making it very explicit. When I come back to this code, I want to remember that I explicitly did not care about the other penguins whose weights we did not have. Another argument you can, another value you can use for the unmatched argument is actually error. So this might be a good starting place where it says, if there's any unmatched cases, just error out. I will stop at that point and read through the error and then decide what I want to do. So the error tells me that each row of Y must be matched with X. And in this case, row 4 of Y was not matched. And now it's basically telling you, decide what you want to do with it. And you might go back to saying, fine, drop that one. So the error value for unmatched is a great starting place, particularly for interactive data analysis. And then you want to explicitly choose one of the values and sort of go with that. All right, so we've talked about joins in new dplyr. Let's talk about one other feature of the most recent dplyr package, which is per operation grouping. So I'm going to start with a very typical tidyverse pipeline here. I want to plot the mean body weights of penguins by species and sex. So I'm going to start with the penguins data set. Just for ease, I'm going to drop any of the penguins for which we don't have body mass or sex information. And then I am going to group them by species and sex. So I can see that this is now a group data frame. And then I'm going to summarize to calculate the mean body weights per species and sex of these penguins. And then let's go ahead and actually make a plot of this. Now you can see that when I make this plot, or even earlier when I just did my summary, there was a message that got printed out. It says summarize has grouped output by species. You can override this using the dot groups argument. So this message, which can sort of catch you by surprise, particularly if you're doing something like creating a plot where summarize is not even the last statement in your data pipeline, is basically saying that you had grouped the data by 2 variables. When we ran summarize, we sort of peeled off that last grouping variable, but the data are still grouped by species. And turns out, for making this plot, it doesn't make any difference. So you can happily sort of ignore that message. But what generally tends to happen is that if we don't address this issue that the data frame is still grouped, this can result in frustrating situations, particularly for new learners, but trust me, even for experienced users, because the data underlying this is now remain grouping, and sometimes this can have downstream effects. It didn't have it on the ggplot, but let's look at a couple examples. So here, for example, I am grouping the data by species and sex again. I am going to find the mean body weights again, and then I want the top row of that output. But if I actually drop my groups, then the top row of that output is just 1 row. So when we have grouping that persists through the pipeline, certain functions will then output slightly different results. And if you were expecting one and you get the other, or vice versa, it can be pretty confusing to try to catch where did this happen. Another example I like to give with this is using the wonderful GT package for making tables. Here I have data that is still grouped after running the summarize function. So the GT package will nicely group my output and display this output for me as such. However, when I actually explicitly drop my groups, that grouping structure goes away, so GT doesn't apply that sort of nice grouping. Which one you want? The idea is you probably want to be explicit about that. So one of the options that we saw is that every time you run summarize, you can decide what you want to do with your groups. You can decide to drop them, which means the remaining data frame is not grouped, or you can decide that you want to assign another value to this, like keep or keep last, for example. Alternatively, with new dplyr, you have a new option, per operation grouping. So you can see that in this new pipeline, I do not have a group by statement anymore. I start with my data frame, I did the dropping the NAs, and then I said summarize to calculate the mean body masses for me, but do that by species. So this new .by argument allows me to do the grouping in the operation where I am doing the summarization, and the resulting data frame is no longer grouped. And I can actually do this by species and sex like we were doing before. And again, the resulting data frame is not grouped. I didn't have to explicitly say, once you're done with it, drop the groups, which I think is a slightly less sort of straightforward or intuitive way of going about things. But here we're just explicitly saying, when you're summarizing, group by these two variables, and when you're done, don't leave the data frame grouped anymore. So my recommendation would be, I think, to consider teaching the .by version of this like per operation grouping, particularly if you find that your learners tend to struggle with persistent grouping in dplyr pipelines. That being said, the new version of R for Data Science, which very recently came out right here, does mention the .by argument for per operation grouping, but it doesn't dwell on it too much. So a majority of the presentation still uses group by, so you can decide based on how strictly you want to stick to the text or not if you are using that text for your teaching. All right, one more bit on dplyr. My most favorite function, case when, for some reason. I really like that function. So now it has gotten some updates as well, some quality of life improvements. Let's start with this. I'm going to calculate some quantiles for the penguins data set. So I have the 25th percentile and the 75th percentile of my data. And using these, I want to categorize my penguins as small, medium, or large. So if a penguin is less than 3550 grams, I'm going to label them small. If they're between these two, I'm going to label them medium. And if they're greater than 4750, I'm going to label them large. And if they were NAs, I want to leave them as NAs. So here, what we're seeing is this would be a typical sort of case when pipeline, where the last row or the last call says, if it's not any of these, so then call it true, and for those rows, label things large. Let's also do something that will allow us to more easily see what's going on in this pipeline. Whenever I have a data frame that's sort of wide with lots of columns, and the columns that I'm operating with, I can't see when I run my pipeline, I like moving them up. So I probably will want to move up here the body mass and the new variable that I created, the bmcat variable. So let's relocate those to move them up so that I can sort of spot check that my assignment is working well. In fact, we might temporarily pipe this to the view function just to make sure that we have some larges as well. So indeed, in our data frame, we do have some larges as well. I have personally always found explaining why we call this true a little challenging when teaching case when, because it's not, you're not necessarily reading out all the conditions. And even if you do, I want to say something like if all else fails. So case when has gained a new argument called .default that basically says if it's not any of those, make it large. So now we can achieve the same outcome without sort of using the true as a catch-all for anything that didn't match. And finally, with dplyr, I want to highlight what I think is a very exciting development with if else, case when, and friends. So let's say that I have my data frame, something like this, and I want to create a new variable that actually shows the units, so the grams, next to the values as well. So let's say I want to have something like this. For each of the body masses, I also want to have a character value that brings together the value and the units. It used to be that you had to type NA character here because all the other values in that column were characters. So now you had to introduce, to do this very simple task of creating a character string from a numeric, the notion that there are different sorts of NAs in R. And I think that's a pretty high level thing to be mentioning. So now you can actually get away with calling this NA and don't have to worry about NA character or other NA variants, where I think they don't necessarily belong as early in an introductory R curriculum as what we have here. Next, let's leave dplyr aside and take a bit of a detour and talk about tidyr and specifically separating columns. So I have a new data frame here, data on penguins with text string description. So maybe you have a different scientist who, instead of putting things in a spreadsheet, has put them in a Word document or something, and you have these three specimens and some descriptions about them. And what you might want to do is take these descriptions and turn them into a data frame or a spreadsheet version. The separate function existed previously in tidyr, but it has sort of evolved to allow for different ways of separating. So one option is to separate, and we want to separate wider because we want to put these pieces of information in columns that go next to each other as opposed to longer into additional rows. We want to separate wider this description column, and we want the delimiter to be the comma. So I want something like this for one of my variables and something like this for my other variable. And I'm going to call those new variables species and island. This gives me something perhaps a bit more useful than these descriptions, but there's a lot of repeated information. So if you are into that sort of thing of writing regular expressions, you can actually take things one step further with a new function called separate wider regex, where you can actually give regular expression patterns to it and in one go result in something like a species column and an island column without the repeated information. If you are teaching regular expressions, I would say this is the way to go. If you're not teaching regular expressions in your class or before you teach regular expressions, you could do something like this and then use some functions from the stringr package like strremove to get rid of the redundant species and island tags here. Another exciting development here, though, is something about what happens when things don't work out as expected. So if you look at the documentation for these new separate functions, you will see some new arguments as well. Specifically too few or too many. So what to do if there are too few components? Should they be aligned at the start, aligned at the end, or should it just give you an error so that you can look into it? Or if there are too many of them, what to do? Should they be dropped or should they be merged with the last one? And the debug option here basically will print out something. It's probably not something you want in your final code, but it's very helpful for interactive use where you can take a look to see what to do and then make a decision in terms of whether a line start, a line, or a line end makes more sense. We've talked about a lot of new exciting updates, so I'd like to wrap this up by talking about something maybe a little bit more lighthearted. So one minor update to ggplot2. This is not the only update I think that has happened to ggplot2, but one that continues to catch me in my tracks is a new argument for changing how your lines look. So for line geom. So if I do something like this, where I am plotting flipper length versus body mass of penguins, and I want to overlay a smooth curve over it, but I want that line to be a bit thicker, you will get a warning that says, please use line width instead of size. I do agree that line width is indeed seems to be more appropriate here in terms of what to call that. And I've in the past struggled with sort of articulating why it was called size. That being said, I will say that the best teaching tip I can give you is just check the output of your old teaching materials thoroughly. Do not make a fool of yourself when you're teaching to constantly see this warning pop up at an unexpected time. So I've tried to go through much of the code that is in the accompanying blog post and sort of interactively explain some of these updates. I should mention and emphasize that much of what I've talked through are things that you can now do optionally, and in places where I feel like that is an improvement in the context of teaching, I try to highlight those. You could also just not do any of these things. Chances are none of your code is going to fail per se, unless there was something happening that was an error to begin with that was sort of slipping through. But I think that these updates are nice to sort of think about as we approach the new academic year, and as you might be thinking about what to change or what to update in your teaching materials. And remember that the tidyverse blog is a great place to catch up with all tidyverse updates, whether teaching related or not. There's been a lot of other updates to the packages that if you sort of dig through this year's posts that you will see, to stringr, to tidyr, to forcats, new API for the rvest package. And also, if you also tend to teach SQL along with your data science content, shorter and more readable, and in some cases faster SQL queries in dbplyr. And I'll wrap up by saying that the new version of R for Data Science is out, and much of the updates that I've talked about here were sort of done in order to catch up with what we wanted to showcase in the book. So you can expect the development to slow down a little bit as you sort of phase in these new changes into your teaching materials. Thank you very much for listening.